session. So, welcome everyone to our session on the impact of prompt engineering on AI performance. In the rapidly evolving field of artificial intelligence, the way we interact with AI systems is becoming increasingly critical. And prompt engineering, the practice of designing and refining the inputs given to AI models, plays a pivotal role in shaping the effectiveness and accuracy of the systems. And this session will explore how carefully crafted prompts can enhance AI performance and making it a more powerful tool in various applications. And prompt engineering is the art and science of structuring inputs to elicit the best possible responses from AI models. By the fine tuning these prompts, we can guide AI to produce more accurate, relevant, and contextually appropriate outputs. This process is not merely about asking questions, but involves a deep understanding of language, context, and the AI model's capabilities. The implications are vast and impacting areas such as natural language processing, decision making, and problem solving across the numerous industries. And effective prompt engineering can lead to reduce the biases, improved response quality, and broader applicability of AI solutions. Throughout the session, we will delve into the practical examples and case studies that highlight the significant impact of prompt engineering on AI performance. We will discuss the like latest techniques and common challenges and emerging trends in this field. By the end of our discussion, we will have a deeper understanding of how to leverage prompt engineering to optimize AI systems, making them more efficient and reliable. Whether you are an AI practitioner or someone interested in the future of technology, this session will provide valuable insights into the critical role of prompt engineering in advancing AI capabilities. Before we start Dr. Jeyalakshmi Jeyabalan session, I would like to give some short introduction about her. So it's our great pleasure to introduce our distinguished guest speaker, Dr. Jeyalakshmi, a senior assistant professor at Amrita Vishwa Vidyabidam in India. Dr. Jeyalakshmi completed her PhD in Information and Communication Engineering from Anna University in 2023, um, establishing herself as a leading expert in her field. Her extensive publication record in reputed international journals and conferences reflects her profound knowledge and significant contributions to the areas of machine learning and related technologies. Known for her engaging and insightful presentations, Dr. Jayalakshmi has been invited to speak at numerous prestigious technical institutions where she shares her expertise on a range of advanced technical topics. Beyond her academic and research achievements, Dr. Jayalakshmi is actively involved in coordinating faculty upskilling programs and technical training workshops for students. Her initiatives is focusing on cutting-edge areas such as big data, machine learning, and deep learning, ensuring that both educators and learners stay at the forefront of technological advancements. As a life member of the Computer Society of India, Dr. Jayalakshmi's contribution have been recognized with the Active Woman Participant Award, underscoring her dedication to fostering growth and innovation within the tech community. Her role as a reviewer for esteemed journals and conferences, including EAI Entos, Transactions on Scalable Information Systems, and the Asian Journal of Research in Computer Science, further highlights her commitment to maintaining high standards in academic research. Dr. Jayalakshmi's prolific body of work includes the publications in high impact factor journals indexed by SCIE, Scopus, and WOS, along with the several book chapters for renowned publishers like John Wiley and IGI Global and Taylor and Francis CRC Press. Her diverse research interests encompass artificial intelligence, machine learning, deep learning, data analysis, and social media analysis and healthcare analytics, showcasing her versatility and broad expertise. We are honored to have Dr. Jayalakshmi with us today. We look forward to her insights on the latest developments and applications in these critical areas of technology. Before the session, I would like to introduce to our services and terms of solutions. We are pioneering this venture. So our company is dedicated to developing the innovative engineering, management, and scientific tech solutions. It tailored to support your ecosystem with our forward-thinking approach. We pride ourselves on offering affordable services and robust support and backed by the professional and skilled team ready to deliver the exceptional business plans. And Terms of Solution is specializes in comprehensive array of services including digital marketing, web designing, server management, on-field marketing, Android and iOS app development, and telecommunications, AI tool, SEO, and web analytics. We are also excel in business operations and process automation across the various sectors such as industrial research, mechanical and automobile, aerospace and defense, electronics and energy, architecture and civil engineering, medical applications, and maritime and marine, agriculture and textile, manufacturing, and more. So, additionally, we are passionate about this education through the Mastering Hub. It's a free platform aimed at unlocking the skills for a brighter future. We invite you to join us in empowering young learners by sharing your knowledge and expertise. So our guest lectures is foster skill development, knowledge sharing, and personal growth, is offering a platform to inspire and educate and connect with an enthusiastic audience to eager to learn. Okay, so I at the end I would like to introduce the motto of Dr. Jeyalakshmi, advancing knowledge through the innovation and education. So I would like to hand over the session to Dr. Jeyalakshmi, and also thanks a lot for joining us today, and over to you, ma'am.
Thank you, ma'am. Thank you for the introduction. And I thank Thames Tech Technologies for the honored opportunity. And we will enter the session now. Let me share the screen.
Yeah, okay.
Okay. So we are into the topic today discussing the impact of prompt engineering and AI performance. This is the era of generative AI, and I understand the audience have a prerequisite knowledge of Python, machine learning, and a little bit of NLP, natural language processing. And this is going to be the agenda of today's presentation. We are going to take a look at what are prompts, prompt engineering. We will be looking at how we are going to generate knowledge with prompt engineering and what are the basic elements of prompts. We will be discussing the basic implementations and applications of prompt engineering, the risks that are involved in prompt engineering, and finally, how prompt engineering accelerates AI performance. And let me start the session with a short introduction on prompts. So, prompts involve instructions and the context passed to the language model. So, this is more this is not too technical statement. We are all used to ChatGPT, Bard, and Gemini. We are very much used to giving questions for expecting responses in literally any area. So we are all becoming accustomed to ChatGPT or Bard, Gemini, all these models. And in order to, we are in an age where this technology is shifting into aggregation into AI applications. So prompt engineering is not only being a field on its own, it's looking at avenues for integration into AI applications. That is why we are talking more about prompt engineering these days. So basically, a prompt is what we are giving as a question in order to get a response from a LLM, a large learning model. So a prompt, literally, it's an instruction along with the context we give to a large language model, and we are expecting it to do a certain task. So it is on itself becoming an area of engineering, prompt engineering. It's a word coined. It's gaining a lot of popularity these days. And this is an area where we are looking at optimizing prompts so that we can retrieve optimal outputs in very less time and space. Engineering is all about optimizing time and space. So prompt engineering is about practice which involves optimizing prompts. So this is also looked at as a essential skill of an AI engineer. So why do we need prompt engineering? I have cut short the need into just three avenues. We see prompt engineering as a key to giving more control over the developer. When a general user, interacts with a large learning model, we can restrict the context of the interactions and reduce the hallucinations and the improper responses if we can go for prompt engineering. We have a possibility of improving the user experiences and manifesting that into business tasks, thereby providing a good user experience. Satisfying the business customers and clients. And when it comes to increasing flexibility, we have the power to optimize the prompts and hence the processes and retrieve good results from generative AI. And these are the basic applications of prompt engineering. We are going to harness prompt engineering while at content creation for blogs or websites. The prompt engineering has gained popularity and it is manifested with the power to even generate code or content, artistic content like images, all these things these days. With acquaintance with generative AI. So we are having the application of content generation, creative content, be it or general content pertaining to the query which is posed by the user. This is largely used for education and learning these days. People are becoming very inquisitive and just putting up the first question to an LLM like ChatGPT or Gemini, and it can be blended to customer service, uh, replacing a teller or a chat bot. So this can give a better experience, adding to the implementation of chatbot. And business research can be more value can be added to business research with prompt engineering. We will look at it. We'll look at demonstrations of this at the end of the session. So we'll get a very impressive idea on how this is helping our business and idea creation or marketing. So be it scientific discovery or any content creation, we see prompt engineering and generative AI to be an assistant, a personal assistant uh, in largely every area. So we look at prompt engineering as a key to knowledge generation. And this is the process, an abstract process flow for retrieving results with prompt engineering to the large learning model of generating AI, generative AI. So we have the data stored in the database, and we have prompt libraries along with the a prompt template with role, task, instructions, context, and inputs, which, when appropriately prompted, is going to give the results along with the cues that are given in the prompts. It's going to fetch the appropriate results using generative AI. And we are looking at knowledge generation. Here we are trying to uh, perform knowledge generation from training of the large learning model or while at inference time. So this is the context that we are talking about. So how do we improvise it? We can go ahead and keep interacting with the large learning model, and in due course of time, the proper questions, the context is already in place, and the proper questions can be answered by the large learning model. This process is called priming. And this is an example of very basic prompt that we are looking at. This is basically a ChatGPT prompt, and I would like to show the example at the end of the session. So when you're just typing in "the sky is" over a large language model, it answers with so many possibilities. Like blue is the first answer, which is the color. It gives indications on weather and all these things as the answer. So this is a basic prompt. So what is going to be the structure of a prompt? It is going to contain major four criteria, the basic instructions, like what the large learning model is going to do. Classification of sentiment is an example that is projected over here. We are supposed to present the context of the conversation. The context is going to be a text over here, and it establishes the purpose. So input data is going to be the text that we feed in. Here it is, I think the food was okay. That is the text that we feed in as input over here, and the output sentiment, it's either going to be positive, negative, neutral based on the text. So if it meant okay, it is either based on training going to give a neutral or positive for a result. So very important thing which we are going to understand with prompts is it is not going to give the same result every time you're going to feed in a question. So what is affecting the query and the result? There are a lot of hyperparameters. One of them is temperature. It is a value that ranges between 0 and 1, and this is largely these hyperparameters are largely based on ChatGPT, and many the name may be different with different large language models, but the hyperparameters are more or less the same. So the temperature is one of the hyperparameters which gives they focus on the responses, how focused the results are. The temperature, if it is lower, if it is like zero point 0.2, it means that the responses are more focused and more deterministic, and it avoids randomness. So this is an example. This prompt, or we have prompted here for describe the implications of quantum computing, and looking at the temperature being low, medium, high, we can see the difference in the responses. The responses are not one and the same. So based on fine tuning the parameters, we can make the responses more specific or medium or largely random. And we can also fine tune the tokens, which is going to be the component of the response. So if we are going to optimally respond with very few tokens, we can dictate so with the max tokens hyperparameter. And this is an example when given a prompt that shows discuss the impact of AI on art creation here. We expect different results based on number of tokens, which we use to restrict the number of words used in the response. So this is an example of max tokens, and there is another parameter top p, which is going to be a nuclear sampling, a probabilistic sampling. It's a hyperparameter which determines the probability of the next token that could be used in the response. Here we see an example over here, which is a prompt says that tell me about the benefits of AI in healthcare, and look at the probability of words. There are three different values of top P, the probability, and three different responses. The probability of words that could be used in the response that is being dictated by this parameter, and the frequency of reuse of the words, the tokens that are used in the responses also can be controlled with frequency penalty parameter, which is going to be ranging between minus 2.0 and 2.0. And this is an example which shows that being minus 2.0, it means we encourage frequent tokens, and a positive 2.0 means that we are going to make infrequent tokens. The words are going to be very much unique in the response, and 0 means the neutral. So these are the hyperparameters we use to fine-tune the responses in a prompt engineering scenario. And when we are going to use iterative prompt design, the prompts, when let us look at this example. So we have different prompts uh, pertaining to a single context. The first prompt says, "Tell me about AI." Second prompt says, "Explain the uses of AI in healthcare." And third prompt says, "Describe the role of AI in diagnosing diseases using medical imaging." And what is the purpose of these different prompts? We can understand all of them fall in one context. When you're expecting a particular response, you can start interacting with the LLM using prompts. You can keep on level wise improvising the prompts so that you can expect the answer that we are expecting to be the right answer. So over here, the designing of prompts are done for different tasks. These are the very this is a very small, a general classification of designing prompts. This is an example of text summarization, which can be done with the help of prompts. Basically, text-related tasks like rephrasing, summarization, or listing out content formats like tables, lists. All this is possible with prompting, appropriate prompting over the LLMs. So we see an example which has uh, summarized the crux of the whole paragraph, which we see here. And this is a question answering prompt. Question answering prompts uh, will take intense training, and we can see that the example shows a scientific example. There is a paragraph pertaining to a research on teplizum, and we see that the antibody can be traced back to mice from the prompt that we are raising. So the question answering can range from the context of a novice to a researcher, and in everybody's perspective, it is going to give answers. The large learning model, if they are properly trained or designed for appropriate business, we can use prompt engineering to fetch appropriate results in like very few iterations, and zero shot is the ultimate target. And coming to text classification, so classifying the sentiment of the text is used to be a decade ago a very big task, but it has become just a prompt away these days with the help of LLMs. And this is a role play example wherein we are expecting the LLM to play the role of an AI research assistant over here. So this LLM starts to behave and interact, converse in the perspective of an AI researcher in the paragraph as we are seeing in the slide. And this is a prompt for code generation wherein the code can be pertaining to, here this is an example for database, and it can be pertaining to any language based on, just you name it. It can be the the specifications based on the LLM, and you can also create from the scratch large learning models and integrate it with prompt engineering to teach programming languages or any language that maybe even just about anything that you would be interested. And this is all about reasoning. What you're seeing here is a slide based on reasoning. It's a question, a quantitative question, wherein we are seeing few numbers and we are asking the sum of odd numbers, and we're seeing the result to be the right one, of course. So this is the reasoning prompt. So these are the very many cases where the prompt engineering can be applied in a more efficient way to fetch better results. And these are a few implementations of prompt engineering, a different perspective of implementation of prompt engineering. We can use static prompts, the archaic ones like how are you or anything like that. So these would not require any template, or you can go for creating templates. Templates are like this is going to be the question, the structure of the response is this. We plan ahead and program it with placeholders. This is the prompt template. As you see here, the slide shows a template for a question and an answer. This is in a different language, OpenAI with the model text dominancy. And this contextual prompts can be largely helpful in avoiding the hallucination issue, which is prevalent in generative AI and large learning models. The prompts and prompt engineering literally restricts the context and hence avoids deviations and irrelevant responses. If we are looking at issues like ethical perspectives to be built into generative AI, this is the key. And when it comes to prompt chaining, we can go for one prompt to kick off another prompt as a chain reaction to establish a purpose. So this is all about prompt chaining, which on the contrary also establishes the prompt pipeline. And autonomous agents, like we can code functions which can be, we will see examples of this. So we can code functions which can be called while a prompt is being executed. So instead of functions, autonomous agents, which are pieces of code which are very independent and can be reused, can be reliably used, and this is becoming prominent these days. When it comes to prompt tuning, the parameters which are not visible to the user, the embeddings, the strings, number of strings, the internal hyperparameters, all these serve as soft prompts to tune the prompts. And these are the essentials that we would need for prompt engineering. The zero shot, this is a little bit of technology. We look at zero shot programming, at least n shot programming, few shot programming. So we are looking at improvisation, though the ideal case is a zero shot programming. Semantic embeddings and vector databases are also the pillars of prompt engineering. Fine-tuning large learning model is ultimately the purpose of prompt engineering. A chain of thought can be established with the prompt pipelines to elaborate on the tasks and the procedure of tasks that are happening, the reasoning that has been done by the large learning model that can be explained and cracked with chain of thought models. So this is few shot programming. When it comes to, we are seeing different versions of large learning model, like GPT-3, GPT-4. It's going on improvising. So what are we targeting? large language models, the issue is the compute power that they consume, and of course, there are shortcomings. We are trying to optimize with the help of few shot programming, nailing the right answers as quickly as possible. And it is possible to improvise with the help of prompt engineering. That's the idea behind integration of few-shot programming and prompt engineering. And this is a small model which is trying to classify using a supervised learning, like classify dogs and cats and birds. So this is a small example. And when it comes to word embeddings, semantic embedding is this is a little bit of NLP. When we are giving prompts in natural language, they literally all the text that is being processed by LLMs, they are being converted to embeddings and word vectors and then embeddings. So, a semantic embeddings make a lot of meaning. The depiction of text, the similarity, their purpose becomes more obvious, prominent with the help of semantic embeddings. These are going to speed up the search and the computational expenses. Coming to large learning model, the fine tuning of the large learning model is very much possible with prompt engineering. That's why it's becoming popular these days. This can be geared up with the help of pre-trained models, transfer learning, and hyperparameter tuning. And chain of thought, this is also gaining a pretty much uh, attention where we are trying to uh, gain insight into the reasoning, the step-by-step way of deriving the answers, how literally when we are improvising over the chain of thought prompting procedures, uh, this can make sense, like how reasoning is happening, and we can use that knowledge to literally solve complex problems or teach complex issues in a much simpler way to users. So this is how it makes a lot of importance. And prompt engineering techniques, these are a few techniques which we are literally focused on. So this is an example. So few short prompts, they can be used for preparing uh, questions which will improve the performance and the precision of the results. In chain of thought prompting, here we can see that there is addition of odd numbers that is being asked here. How it is being derived, that is being explained with the chain of thought prompts. Literally, the odd numbers identified and then they are summed up. The steps are being narrated over here with the chain of thought prompts. And zero shot chain of thought combo. Here it helps us to understand things literally very easily and also clarify and improvise the results. See, this is a problem here. We are dealing with an analytical problem in the slide. We have a question wherein a person buys 10 apples and he is literally passing two to the neighbor and two to the repairman on the way, and procuring five more apples and each one of them on the way. So how many is he left with? The LLM model answers 11, but when we are trying with a chain of thought model, when we are reasoning out, we can see that the stepwise results, of course, the last answer was the wrong one. So when we are looking at the reasoning and the stepwise uh, breakdown of how the answers are derived, we are able to retrieve the right answer eventually, which is 10. And this is how we are able to improvise the models. And we are always bothered about the self consistency, like whatever way you're putting up the query on the prompt, the answer is supposed to be correct. The prompt is a vernacular language uh, statement. So when you're rephrasing it or putting it in another way, it is going to always fetch you the right result. So that is the self consistency. Uh, this is a question here. When I was 6, my sister was half my age. This is a very tricky statement. There is a question following that. Now I'm 70. How old is my sister? This answer is this correct? The LLM is it's giving 35, which could not be a reasonably correct answer. So the difference of age between the siblings is 3. It was 3. And the interpretation of the statements that can mislead the results. So this self-consistency is supposed to be coded with the within the LLMs, and the prompts can be made more precise and relevant. So this is following that problem. It's the same one narrating how we can fetch consistent results with appropriate prompts. So we have a prompt saying that when I was 6, my sister was half my age, so she was 3. Now I'm 70, and so what will be her age? So that means that the present. Okay, there is also one more thing which we would add here: the training of LLMs and the tuning of prompts both go hand in hand. It is if the prompts are going to be very good and LLMs are not trained, so it is not going to make a good pair. So it's a combo of both. So over here, the prompt fetches the right answer, which is 67 over here. And this is a knowledge generation prompt. Literally, the slide gives the flow of a task which we have discussed already. And over here, we can see that there is a question pertaining to the purpose of playing golf. We can see two different answers. The one answer pertains to the purpose, the process of golf. The other is about competitive nature of a game. Uh, so we evaluate the prompt engineering internal engines are supposed to evaluate both the results, the LLMs along with it. So they are going to evaluate the high confidence predictions and give away those. So this is also a tricky nature and the issue with pulling out the right results. So one, we are thinking of improvising. Program aided language models are coming into picture, which largely help us in chain of thought, improvising chain of thought. This is an example over here. We can see a very good example between chain of thought and program aided large learning model. Over here we can see that there is an analytical question being posed here, which is wrongly answered by a chain of thought model, but it is very correctly answered by a program-aided language model, which breaks down the analytical question to variables and values and works out a program, like a program, works out expressions based on, rather than reasoning, it is being converted to a expression evaluation. So this gains much confidence, and the answer literally is the right one. And this is still gaining a lot of attention, React model, wherein we are looking at improvising the reasoning part. So this is a question. We are seeing an example over here. Aside from the Apple remote, what other devices can control the program Apple Remote was originally designed to interact with. So we are having different solutions over here. A standard one with an Act setup and React setup. So here we are able to see. So the literal result is going to be a keyword before Apple remotes. Because this is the literal answer that we are expecting. But when it comes to the models, we can see different answers which are wrong. Coming to the React model, we can see how a statement is converted to thoughts, actions, and observations. Based on these, the results are fetched. So this is the purpose and the importance of React frameworks in prompt engineering. Directional stimulus prompting, this is also a improvisation based on reinforcement learning. We are trying to use LLM along with reinforcement learning, which brings in the concept of rewards over existing policies, uh, and actions, environment over which we are expecting certain actions. If it is a positive one, we are rewarding it or punishing based on negative actions. So this is how the directional stimulus prompting works, wherein this is also a technology which is giving better results. So this is an example which gives a better result over here. This is rogue one, which is fetching directional stimulus prompting based answers with remarkably thorough insight into the paragraph that is given, and based on the prompts it is just summarizing the right way. And now coming to the issues that could be possible and in prompt engineering. A prompt injection is a vulnerability that is already there in prompt engineering. So someone can modify the prompt, inject a prompt, a wrong one, to misfetch a wrong response. So this is a prevalent problem, and prompt leaking is also a inherent issue where a person forces the model to retrieve information which the large language model is not literally programmed to give. So this is an example that we are giving here, where we are seeing here by means of different statements, different instructions, the person is trying to retrieve the last uh, prompt that was given to the large learning model. So this is a prompt leak. And jailbreaking is another prompt injection issue. Here we are seeing a possibility where a person is asking a large learning model to it's a prompt saying the model to fetch a poem on a hot wiring a car. So the large learning model gives a reply stating that it is literally not capable, but then on forcing it with the next prompt, it literally gives away a poem. So this is also a literal prompt injection, which is fetching uh, improper results. So how prompt engineering can literally be used for betterment of AI and its performance. So prompt is a tailored instruction. This will, as we discussed, bring proper context and hence avoid misappropriation. So this is how the time and space of the large learning model can be saved. We can go for high accuracy and relevance of the results with the zero shot learning and the reduction of the hallucinations. You can see hallucination and its results. So this is the comparison between two different models giving away responses. The hallucination part is evident over here. So to avoid that, proper prompt engineering is a proper key to avoid it, and enhance creativity and exploration. Unlocking creativity from the LLMs is the purpose of prompt engineering. Uh, so this we can discuss more with the examples, so we can fetch faster results with the help of prompt engineering. LLM is not only an entity, it is having a lot as a trade off. LLM is a large learning model which um, literally is a really big large learning model which dissipates a lot of heat. The inherent global warming is an issue. We are supposed to use it with care, with a lot of attention. So prompt engineering improves the way we can harness LLMs, large learning models, usefully. So we will go into a demo. So this is Gemini, with which I'm just focusing on certain examples of how prompt engineering is being used. So before we go ahead, how are we going to use Gemini in Collab? This is our Collab notebook. Uh, so Gemini goes with AI Studio. Google gives away the configuration API keys. So this is where we are supposed to retrieve the keys, and we are supposed to copy the key and configure in Google Cloud. So this is a Google Cloud wherein we are seeing a key icon over here. This, when you click on it, I have this previously configured. This is a Google API key. This is the name of the parameter and the value I have fed in here. So this will integrate the credentials of using Gemini in Collab. With that, that is pretty simple as compared to any other proprietary model. So this is an example. All these examples available online with Google Research, and this is um, a prompt example, a case study showing Apollo 11 transcript. Okay, we have installed Google Generative AI. I would literally move on to the prompt part. We have loaded the data set. The data is a text, which is a transcript of Apollo 11 conversation. And we have loaded the text file, and we are Gen AI. This a large learning model is uploading the content and is ready to interpret the content. Now we are programming a prompt which says find four light-hearted moments in this text file. So we are using a model. We are supposed to specify the model, the generative AI large learning model. Here it is Gemini Flash. So the response keyword fetches the generated content from the model, and it is displayed over here. This is a simple Python code. We can see statements, exactly four answers, which are highlighting the appropriate answer. So this is the first example. We move on to the second one. This is a similar example wherein we use role play. So this is an example which shows role play while at prompting the large learning model. So model, Gemini Flash, system instruction, you can see you are a cat and your name is Nika. So the large learning model is actually building a response for a good morning with per as a cat. And this is another example wherein the LLM is prompted to be a parrot. And the response, as you see, is a raw matey. So this is a different context with different roles. This is an example of a role play. And we can see a different example with function calls, wherein these are functions to turn light on and off. Stop lights is a function. You can see it's a small function uh, which will not literally activate the real uh, devices, but it's a text response as a printed uh, text on the console. So stop lights is one function, set light color is another function. We are giving an instruction, setting an instruction. We learned this while we started out with prompts. Prompts need instruction, context, role, all such content in order to generate a response. So this is the instruction. You are a helpful lighting system, but you can turn lights on and off and you can set the color. So this is the instruction that we have given. So this is Gemini Pro, and that is ready, and we are calling the function tool config from mode. So over here we're configuring the functions, and now we are prompting to call the function, and you can see that the text that we configured is getting displayed. I can turn lights on and off for you, and that was one. The other one is about enabling lights or changing the color to purple. So these are functions which are triggered from prompts. So this is another case, and this is a different one, a very interesting one, wherein we have audio being integrated into prompts and Gen AI, and we have a audio of John F. Kennedy's speech on 30th January 1961, and this is fed as an audio. This is fed into the system, and there is a prompt here saying the LLM should listen the file and summarize it. This can even be done with a video, which is very much possible with Gemini. And over here, the file is being read by the LLM, and the response is the transcript is being displayed. So this is an example showing the count of tokens in the transcript. So a lot can be done Gen AI and prompt engineering together as a powerful combo. And this is the most interesting part, wherein we are using prompt engineering for uh, improvising marketing campaign. There is a jet backpack which is being designed by a company. We are trying to get the help of the LLM along with prompt engineering to improvise and run the campaign to impress the clients. So this is the sketch of the jet backpack, and we are prompting and analyze prompt here. So the image is being analyzed by the LLM, and we are describing the image in response. Now, this is where things get interesting. We are prompting the LLM. This is a prompt where we I literally read out the prompt. You are a marketing whiz and writer trying to come up with a name for the product shown in the image. Come up with 10 varied interesting possible names. Return the result in array format so you can specify exactly what result in what format you're expecting. So this is being expected from the backpack descriptions given to the LLM, and now we are requesting it to create with campaign with ideas uh, literally suggesting why a person could buy the backpack with the inscriptions. We are requesting the LLM to create a web page. This is the prompt showing the purpose, and we can see that code is being generated. We can recognize the H1, H2 heading tags in HTML, and B, along with the code, we can see the responses. So by all means, Gen AI with prompt engineering is a great pair to improvise the results. So these are all possible outcomes in corporations for creative purposes. So I think that served the purpose, and I think this little slides where the lecture was informative and shed a little insight into how prompt engineering can be used along with different AI applications. Let me finish off with a final note. Uh, when we are going for customization, for example, when we can integrate LLM along with prompt engineering and explainable AI, we can build powerful healthcare applications or business applications to bring the results or satisfy the customers, which can largely decrease the manpower and improvise the services and the scientific uh, richness, also preserving the information. So this is the power of the technology that we are looking at. So with this note, I would like to close the session, and I thank Ma'am Sugandhi for giving me the opportunity for the session. Thank you.
Yeah, thank you, ma'am. Thank you so much for the wonderful presentation. And I have some questions here. Okay.
Yes.
So the first one, how can the advancements in prompt engineering techniques improve the robustness and adaptability of AI models in handling the diverse and unstructured data sources?
Excuse me, ma'am. Can you please repeat it?
Yeah, sure, sure. How can advancements in prompt engineering techniques improve the robustness and adaptability of AI models in handling diverse and unstructured data sources?
Okay. So there are technologies coming up which can help us uh, bridge data sources along with LLMs and prompt engineering and build applications to fetch results. Now the question is how precise the answers are. The LLM has been pre-trained for a purpose, and it can give you results. But how precise are they? That that problem can be bridged by prompt engineering. It can fine tune the proper questions to fetch proper results. Uh, we have seen through the slides technologies like few shot programming and semantic uh, embeddings. All these technologies can help to improve prompts and thereby enrich the results of large language models. So, however abstract uh, the prompts are in vulnerable in vernacular language, the results can be improvised with these technologies.
Okay, okay. Thank you, ma'am. Thank you so much. And what role will prompt engineering play in the development and enhancement of AI models for real-time applications such as autonomous driving and real-time language translation?
Okay. Uh, I'll start off with healthcare.
Yes.
Now, let us assume there is a image of a MRI or just about any image like an X-ray. So, if we feed the image, now literally we are supposed to have a medical expert look at the image and interpret it. What if we can have a LLM When we can feed the image, it can interact with the patient and understand the issues of the patient, be secure, and also serve as a medical companion to the patient. This is the power of combo of explainable AI. This is literally a large project, but this is the scenario that we are looking at. This is a possible application which is coming up these days and pertaining to um, the translation of text. Uh, this is code. So when it's integrated, I mean, when it's dragged to concepts of language translation, literally the applications of n in number. You can use the combo for teaching a language, maybe even Tamil or English to students, or math to students, or uh, translate language between two different languages to a tourist. The applications are n in number. It is just the integration into end-to-end fashion. So that is the capacity of LLMs and prompt engineering we are looking at these days.
Yeah, thank you, ma'am. Ma'am, how can the prompt engineering be integrated with other AI optimization techniques such as reinforcement learning and transfer learning to further enhance model performance and efficiency?
Like we discussed just now, ma'am, the disjoint. I would just like to go back to the slide. Just a second. I think the slide is visible now.
Yeah,
So
yes,
this
ma'am.
is directional stimulus prompting. You can see there is an input which goes into a policy learning machine which has a policy. So we are having inputs, literally prompts. They are coming in to the policy. Literally, this RL over here, which is a label, is reinforcement learning. So the LLM takes an action that, if it is uh, leading to the proper responses, it is positively rewarded, else it is negatively rewarded. And in iterative fashion, we are able to retrieve the appropriate results, which are very precise from the LLM with the help of prompt engineering. This is the idea behind directional stimulus prompting. This is a research concept which is prominent these days. I
Oh,
think
thank you.
that
Yeah,
answers your question.
okay.
And coming
Thank
to transfer learning, when it comes to transfer learning, it is a pre-trained model which is itself for improvisation of results, the accuracy of the results. So that can also be integrated into these concepts to improve for improvising the results.
Yeah, thank you, ma'am. Thank you so much. So thank you for the useful answers, ma'am. The questions are over from here. So the answers are very useful. I hope the access and that the participants can understand about that. So finally, so ladies and gentlemen, it's with great pleasure that I extend our heartfelt vote of thanks to Dr. Jeyalakshmi Jeyabalan, for her enlightening and thought-provoking presentation today. So, Dr. Jeyalakshmi, your insights into the intricacies of machine learning, artificial intelligence, and their applications have not only broadened our understanding, but have also inspired us to explore the new avenues in our respective field, and your depth of knowledge and the clarity with which you share the complex concepts in truly commendable, and we are deeply grateful for your time and your effort in preparing such an engaging session, and your contributions to academia and your active involvement in advancing technological education are truly inspiring. So the practical examples and case studies you discussed have provided us with valuable perspectives that we can apply in our work and research. So on behalf of everyone here, I would like to express our sincere appreciation for your invaluable contribution to this session. Your dedication to advancing knowledge and fostering innovation is a beacon for all of us. And thank you, Dr. Jayalakshmi, for sharing your expertise and for being such an inspiring and influential figure in the field of technology and education. We look forward to future opportunities to learn from you and collaborate with you. And just once again, ma'am, just 1 second. And on behalf of Mastering Up, we present this virtual memento as a tribute to our guest speaker, Dr. Jayalakshmi. Your insightful contributions have enriched our knowledge and inspired us profoundly. This token of appreciation symbolizes our gratitude for your expertise and dedication. So, thank you for your sharing your wisdom with us and shaping our understanding in profound ways. So, thank you, ma'am. Thank you so much.
Thank you, ma'am. I'm literally honored by your memento, and I thank a lot to Thames Tech Solutions and Madam Suganti for encouraging this lecture and giving me this wonderful opportunity. Thank you, ma'am. Thanks a lot.
Yeah, thank you, ma'am. Thank you so much.
So let me close the session.